Hi everybody and welcome to part 2 of this week's lesson. We're looking at curved mirrors, and in particular we're going to look at concave mirrors. Okay, so what I want you to be able to do by the end of this lesson is draw ray diagrams for concave mirrors in order to predict the image that they're going to make. Earlier in this lesson, what I had you do was look at your image in a spoon, for instance, your reflection in a spoon, and see how it changes when the spoon is close, when it's far away, when you use the front side, when you use the back side. Now what I want you to be able to do is kind of understand what's happening with the light in those cases. So concave mirrors follow the law of reflection, just like plane mirrors do. When parallel light rays hit a curved surface, each ray will reflect at a slightly different position. Okay. And these rays eventually meet at a common point, which is called the focal point. And this will be important when we go to draw our ray diagrams. We're going to use that focal point to help us sort of frame our ray diagrams. The middle of a curved mirror is called the vertex. This is another handy point to know about. We can use it in our ray diagrams as well. So the vertex is sort of the most rounds or the highest point of the rounding of the mirror itself. So on our diagram here, what I want you to notice, this red line, we call that the principal axis. Okay, the focal point's labeled here for us. It's right there. The vertex is this highest point right here, right where the mirror meets the principal axis. Okay, and then we also have a thing called the center of curvature, which is twice the distance of the focal point. Okay, it's sort of like if we were to continue our mirror into like a circular shape, it would be sort of the center of that circle. A quick review of images. So remember we talked earlier this week about virtual images, images that aren't really there. They appear to be coming from behind the mirror. We know that can't be possible because the mirror itself is opaque. The other type of image you can get is what's called a real image. That's where the mirror would really project an image onto a screen if you were to put it there. These are called real images, okay? And a concave mirror can actually form both real images and virtual images. So when you did the spoon experiment, what you were noticing was both a real and a virtual image. So what I want to do now is walk you through how to draw these. So what I'm going to do first is I'm going to get out my ruler again. And again, I'm trying my best here to draw these. I don't have my stylus with me, so I'm drawing them freehand with my index finger and trying to draw them as best I can. Okay, so what you're going to do is you're going to get your pencil out and your ruler, and you're going to have it kind of set up like this. And the first line we always draw comes right across the top of our object. Okay, and it hits the mirror, and then the angle that it comes back on, you can always figure it out very quickly. It just goes back through the focal point. Just like that. That's step one. So we draw a line like that. It comes from our object, hits the mirror, and bounces back through the focal point. Anybody who's played hockey or ringette will kind of recognize this pattern. It's very similar to when you shoot a puck against the boards or the curved end of the boards. You get a bounce back like this, very similar to this. Okay, in step 2, what we do is we draw the opposite line. So I'm going to maybe just choose a different color here. And now I'm going to draw through the focal point to start. And then I'm going to have it bounce off those boards, off the mirror. Okay, and it's going to bounce straight back like that. In step 3, what I'm going to do is I'm going to show both of those lines that I just drew. So there's my lines drawn in again. And so what I'm going to do is figure out where they meet. And I'm just going to put a little dot there. Okay, and that little dot is going to show me where I'm going to start drawing my image. So in the next section, what I'm going to do is where those lines meet in step 4, I'm going to draw in my reflected image. So there's my lines again. And then where they met was my black dot there. And now what I'm going to do is I'm going to draw in my reflected image. So what you'll notice is that my light originally was leaving the top of the arrow up here. Okay, so the top of the arrow is where that light meets again right there. So I want to make sure the top of the arrow is where the light meets. The bottom stays on that principal axis. Okay, so that's how we draw these ray diagrams for a curved mirror. And one of the things I want you to notice is, I'm just going to clean it up a little bit, you get kind of this neat sort of skewed hourglass shape when you draw these. So for concave mirrors, when you draw a ray diagram for them, you get this kind of skewed hourglass shape, and that kind of tells you that you're doing it right. Okay, so let's draw one more together. This is just for practice. Okay, you don't have to write this down if you don't want to. Okay, I'm just going to walk you through the steps again. So I'm going to draw a line straight across to the mirror, and then I'm going to get my ruler turned, and I'm going to draw it down through the focal point. Okay, and then I'm going to draw my second line. It's going to go down through the focal point, and it'll come straight back. And wherever they meet, that's where I'm going to draw the top of my image. So again, this was a blue arrow. It'll kind of look something like this. Again, I apologize. I'm using my index finger here, so my pictures aren't as sharp as I'd like them to be. But that's in essence how you draw it for a concave mirror. This should jive now with what you saw when you were looking at the reflections you were getting from the spoon. When you hold the spoon far away, you should actually see yourself upside down and a little bit smaller in the reflection. Now, what happens when you got yourself close to the mirror? Let's have a look at what happens here. So what I'm going to do is I'm actually going to bring my picture over a little bit, okay? And I'm going to try to draw my lines like I do normally. I'm going to draw a straight line across the top and come back through the focal point. That was that first line that we always draw. Now, the trick here, I can't draw it down to the focal point. So that's unfortunate because that was the second line that I was drawing before. I'm actually going to choose a different spot. I'm going to draw down to the vertex. And what I want you to notice about the vertex is that right at the vertex, it's very flat. It's actually kind of like a plane mirror. And so what I'm going to do is I'm just going to do what I did for plane mirrors. Now, I'm going to look at these light rays that we've created, these reflected rays. They don't look like they're ever going to meet. Okay. Now, if you think back, though, to when we did plane mirrors, the rays didn't meet in the front. They actually met in behind. So what I'm going to do is I'm going to trace these back like this, trace this one back like this. And where they meet is actually where my image is going to be. And this is maybe something you notice when you held the spoon close to your nose, is that the image that it created was right side up, okay, but it was actually really large, okay. And so where this gets application is in mirrors where we need to enlarge something. So if we can bring the object really close to that mirror, then we can make it look bigger in a curved mirror. So for instance, like makeup mirrors work on this principle. So you want to see details of makeup as you're putting it on, okay. A curved mirror allows you to get a larger image, which allows you to see better details of what you're working on. So that's concave mirrors in a nutshell. If you have any questions about this week's work, please feel free to email me. Try the ray diagrams if you have time. If you don't, that's okay too. The important thing to get handed in this week is the concave mirrors lab. Again, if you have questions, please feel free to email me.